Hey guys, it's Emily. So the name of the project that I decided to dive a little bit more deeply into was M2C3, Mathematical Modeling with Cultural and Community Contexts. So for project contact info, the main person who spoke in the video was Aaron Turner from the University of Arizona. But when I Googled this topic, I also saw a website from Julia. I'm not sure how to say her last name, but she's from the University of Washington, Tacoma. There were some other people who worked on this as well, and they are listed in the website that I'll provide. So I did email both of those two that I just pictured. However, I have not heard back from either of them yet. So I'll update you if I do. So for the project description, I took this from the website that Julia had posted some information on. Mathematical modeling with cultural and community context is a project focused on teaching and learning mathematical modeling in diverse elementary classrooms. Math modeling skills are foundational as they connect core math ideas to real world experiences through analysis, representation, interpretation, and revision. Mathematical modeling also supports enduring understanding and practices in math, such as problem solving and generalization. I think a big takeaway from that is that problem solving is such a big thing. So the National Science Foundation will fund a 3-year, $1.5 million research project to study teaching and learning of math modeling in elementary education. This website here has a bunch of information that Julia, who was the second person pictured on my front cover, um, she shared a lot about this. So this project connects to students' interest through lessons about sports, food, gardening, home and community activities. I'm going to show you an example of one, but it really does connect to the idea that like if students don't know why they're learning something, they're not going to be very interested in learning it. So it's really answering the question for them of, well, what's in it for me? It also encourages children naturally by piquing their curiosity about things that interest them. The goal is to get away from the plug and chug method. And then this page here is an entire page for the project personnel, so everybody who worked on this. Down here is a really great example of some of the resources this site offers. I'm going to click on this. And then, ooh, I already had it open. So one of the examples is about a pizza party. So if a classroom had a pizza party, they basically would have to figure out how many slices of pizza or how many pizzas are they going to need. So if I click on pizza party lesson overview, oops, this is giving us the standards. That's not what I meant. But here you go. This gives us extra information. Um, Lesson slides. So here, this is kind of like an overview of the whole thing. Okay. So one question they're going to answer is, what do you notice? What do you wonder? What if our class had a pizza party? That's kind of like the guiding question. How many pizzas will we need to order? What do we know? So what do you already know about pizzas? How are pizzas cut? How many slices does a pizza usually have? And then what do we need to know? So this is here as a resource for you to use. And then what I really liked is they also gave some examples of student work. So you can see we're writing in sentences, we're showing fraction visuals, we're seeing multiplication equations. And you can see that from student to student, it changes a little bit depending on how that student is probably processing and also probably based on that student's background knowledge and what they're comfortable with. And this obviously could look very, very different depending on the students in your classrooms. I'm going to click back here. So how does this align with how students learn and my own STEM perspective? It goes beyond just math with the ability to create an end product. I'm not sure if I said this or not, but in the one example in the video, students wanted to kind of look at the issue of recycling. So they wanted to see how many plastic bags they could recycle in order to make a jump rope. So they ended up with an end product as well. It helps students make sense of their learning. They had tons of time to collaborate with their peers. It requires them to not only have factual knowledge, but conceptual as well. Draws on their background knowledge for sure, especially with that pizza example. It helps students learn how they learn. So are they more of a visual learner, a hands-on learner? And it's certainly a learner-centered classroom environment. And then it aligns to my STEM perspective because of the integrated disciplines. So summary of findings from additional research. So we know that mathematical modeling now is a process of using mathematics to analyze a real world problem. And it represents it using mathematical concepts to make predictions and take action. So they believe children are naturally curious and observant. Their experiences and knowledge from their homes and communities can help them make sense of complex issues and situations they encounter. And then the researchers want to work with teachers to modify traditional textbook story problems, which usually only have one correct answer, into mathematical tasks that reflect community situations and may have multiple answers depending on assumptions that students identify. There's this is their general website, and there's a ton of resources on their website for teachers. So my explanation of why I chose this project to review, it applies to the elementary level. I'm a math and science teacher. It really answers the question for students, what's in it for me? Connect students to real world problems. It's engaging for students, but it still meets grade level standards, which is everything. And then students can create finished products in some cases. And then how this project informs my own teaching and learning, it really caused me to think about my own teaching methods and what I'm doing compared to what this looks like. It piques my interest of what I could change to make learning more engaging for my students. And it's a great example of integrating other areas with math as well. So thank you guys very much. If you have any questions, feel free to ask, but I also encourage you to check out this video. Thanks.